Hello friends, in the last video, we saw everything about lines, angles and triangles in a greater detail. I am sure, I hope you all are very well versed with that now. That is sorted, fully in mind. Now let's go one step further and explore as we have discussed second topic, polygons and quadrilaterals. Okay, now the word polygon we have already heard about in the last video. So basically triangle was nothing but a polygon only, right friends? So polygon is nothing but n-sided closed figure, and to have a closed figure we need minimum 3 sides. So poly is nothing but many, gons means sides. Yeah. So any closed figure having straight line sides. So n-sided closed figure is called as polygon, where n is minimum 3. Check this: polygon, polygon, polygon. All were closed, right? That is why. Now, two types of polygon, convex and concave. How do we differentiate this? Convex polygon. Check this. Can you see all the internal angles? All the internal angles are less than 180. None of them is more than 180. So this is one main feature of convex polygon. Every interior angle or internal angle will be less than 180. What happens because of that? The line joining any two vertices will always lie inside the polygon. Okay, friends, check this. And generally we call them as diagonals, isn't it? You can see all these polygons, they are nothing but convex polygons. So when the interior angle is less than 180, कोई भी line अंदर कोई भी दो point लो in fact and join them, that line will be completely inside the polygon. Okay, because of the interior angle being controlled like this, it should be less than 180. Yeah. Now concave, exactly opposite. There will be at least one angle which you can see here, which will be at least one interior angle which will be more than 180. So if the interior angle is more than 180, if you join the 2 points inside the polygon, that segment joining the points will fall outside the polygon, isn't it, friends? Check this. Yeah. So this is the simple identification of concave polygon. These are all concave polygons because at least one angle was there which was more than 180. All right. Cool. Now let's see all the names, all the famous names. 3 sides we already know: triangle, 4 sides, quadrilateral, not square or rectangle. Huh? That is a specific name. General name of 4-sided polygon is quadrilateral. 5 sides, pentagon. 6 sides, hexagon. And quadrilateral is our main aim after polygon. All right. 7 sides, heptagon or septagon, both are fine. 8 sides, octagon. 9 sides, nonagon. 10 sides, decagon. This much is enough. Itna kafi hai. Okay. Now regular polygon. What do we mean by regular polygon? Yes, polygons having equal sides and equal angles. Okay. So when all sides are equal and all angles are equal, we call them as regular polygons. Will this be a regular polygon? The last one, this one. Correct. It won't be, because only sides were equal, angles were not equal. But now, yes. So this is nothing but a square. So both of them should be there. All sides and all angles. Cool. Now some properties, important. Sum of all the interior angles of a polygon, yes, is n minus 2 into 180. Correct? Let me just give you a small brief about this. Suppose if I take a pentagon, now I can split this pentagon into 3 triangles like this. Why am I splitting into 3 triangles? You know, I want to cover all the interior angles and my base of thinking will be triangle, because I know sum of all the 3 angles of a triangle is 180. So I am exploiting that fact only, friends. So here A plus B plus C is 180. Yeah, DEF 180, GHI 180. So if I add all of them, it will be 180 into 3. Yes, which helped us to cover all the interior angles of this pentagon. So 5 sides were there. So we saw 3 triangles getting formed. In quadrilateral, 4 sides are there. So we can take care of all the interior angles with the help of 2 triangles. That's the pattern. Always 2 less. In 4 sides, 2 triangles. In 5 sides, 3 triangles. Similarly, in 6 sides, 4 triangles, and so on. I hope you got it. Yeah. So here all of them will add up to 5 minus 2 pentagon, right? 3 times 180, that is 540. Okay. All right. This one 7, right? So 7 minus 2, 5 into 180, that is 900. Septagon or heptagon. Now some of the interior and an exterior angle, very easy to visualize, right? 180 degree. Check this. So P plus C is 180, D plus Q 180, and so on. Yeah, so interior plus exterior will always be 180 degree. Then sum of all exterior, if you remember, we have already done this in triangles. We have derived this. Sum of all the exterior angles will always be 360 degree. This will be true for any polygon. Yeah. So check here. So PQRSTUV addition will be 360 degrees. Okay. All right. Now regular, each exterior angle. So if you want to generalize the value for each exterior, sum of all of them is 360. So divide by number of angles, because all of them are equal and their addition is 360. Spread 360 equally into n such angles. See this. So 360 divided by 5. 72. Okay. Each interior angle, yes. 180 minus each exterior, simple, isn't it? Because interior plus exterior was 180. So use that fact. 180 minus exterior. Finding exterior is very easy, friends, right? Just now you saw 72 aaya tha, so 180 minus 72, 108 in this case. All right. Then perimeter, very easy because all sides are equal. So length of one side added n times. So in short, n times length of each side. Correct? So here it will be 5x because there were 5 sides all equal. Regular pentagon. Area. Now how will you derive area? Yes. Understand. Break it down into known shape. Now our best known shape is triangle. Triangle. So we can split this into triangles. We have 6 thoughts for triangle, 6 thoughts of area for triangle, right? So area of one triangle into number of triangles, because in a regular polygon, all will have same area. So see, you can derive the area of that one triangle, half into base into height into n. What about this n into x? X plus x plus x plus x n times. So n into x. So ultimately, perimeter, isn't it? Total boundary is getting covered. And half into boundary, half into perimeter, absolutely semi-perimeter into h, the height. Yes. So in this case, 5x divided by 2 into that h. Yeah, and what is h? It's the distance of the center of the polygon from any of the sides. So that perpendicular length, distance of a point from a line, remember? Okay. Area of a regular hexagon, for example. Yeah, so area of regular hexagon, semi-perimeter into height. So 6 into side was the perimeter, so half of that, so 3 into side will be the same perimeter into height. Height matlab, remember in regular hexagon, each of these triangles will be equilateral triangle because these two are equal and this angle is 60. So whenever in an isosceles triangle, friends, if one angle is 60, automatically all the 3 angles will become 60. So all 3 sides will become equal. So it will get converted to equilateral triangle, isn't it? So height of the equilateral triangle we know very well, friends, root 3 by 2 into side. So ultimately 3 root 3 by 2 into side square, or simply said 6 times area of one equilateral triangle. That is also enough, friends. That is the area of a regular hexagon. Understood? Okay. Cool. Let's go ahead. Now specifically quadrilaterals. Polygon in general is done. So polygon is done. Now quadrilateral, first of all, 4-sided closed figure. This is I have drawn as general as possible. Yeah. So 4 interior angles. So sum of all of them will be n minus 2 into 180. So 4 minus 2 into 180. So 2 into 180, 360, right? Yes. Area. Now what will you do for area? Again, the known shapes. You can split this quadrilateral into two triangles, isn't it, friends? Yeah. So sum of areas of both the triangles we can develop as height into base, base into height. Yeah. So half d into h1 plus half d into h2, half d common. So h1 plus h2. That is one way, friends. Second way, if you know both the diagonals, remember this will be used quite frequently. If you know both the diagonals and angle between the diagonals, it can be this angle, this angle, this angle, this angle, any of them. All four of them will give you same logical answer because of sine. So area formula is half into product of the diagonals into sine of angle between them. These two were vertically opposite and this is supplementary. And there's one simple fact from trigonometry, sine of 180 minus theta. The answer is exactly same as sine theta. So don't worry about this. You can take any one of these four angles. No worries at all. Okay. These two formulae. Great. Now, the way we explored the family of triangles, same way, let's explore the family of quadrilaterals. On what basis we classify quadrilaterals, friends? There we had classified on the basis of sides and angles. Here on the basis of how many pair of sides are parallel to each other. If you see there are two pairs of sides, right? Quadrilateral. So two pairs of sides. Now three cases will exist if you understand. If both the pairs are parallel, it's a parallelogram. That particular family will be parallelogram family. If only one pair is parallel, yes, trapezium. The name of this is trapezium. And if nothing is parallel, any general quadrilateral. And one such famous example in that family is kite. Kite is not the only one, it can be any general quadrilateral. So this is like segregation of quadrilaterals. Let's explore each of them in detail. First, parallelogram. Maximum chunk of the content is in this only. Trapezium and kite are the least. Okay, it will be easily done. Now see this flow chart, very important. So in this parallelogram, if all sides become equal, friends, then this parallelogram gets converted to perfect rhombus. And if you see all angles getting equal, so like this it was all angles being equal, so each angle will be 90 because sum was 360. Rectangle, hold on, square baki hai, abhi nahi aaya. If you see both of these happening, that is all sides equal as well as all angles equal, it is square. Student friendly figure. Yes, safest figure. And by the way, regular polygon. Yeah. Now let's see the properties. First, the general properties, like the feature of all four of this. Feature of entire parallelogram family. The first one, opposite sides are equal and parallel. I hope you are noting it simultaneously. Opposite sides are equal and parallel. You can see in all of them. Second, opposite angles are equal. In rectangle and square, you can see this with naked eyes, but in rhombus and parallelogram also it happens. You can easily derive by taking two triangles. Both the triangles will be congruent. You can easily derive this. Okay, see this. Great. Interior adjacent angles are supplementary. That is natural, right? Parallel lines and a transversal. So everywhere. In rectangle and square, it was visible with naked eyes, but in rhombus and square parallelogram, you just saw that x plus o is 180. Fourth point, diagonals bisect each other. They don't only just meet, but they meet at midpoint. So diagonals bisect each other, friends. They bisect each other. So these are four general points. All right. Cool. Great. Now, one more thing, area of the parallelogram, base into height. So this is the base, draw a perpendicular, h, so b into h. You can also take the base as this one, a, and then height on that. Okay. Yeah. Or you can actually do it like this also, ab sine theta. Basically, draw a diagonal which will give you two triangles, half AB sin theta two times, because opposite angles are equal, right? So this will also be theta, this is also B, this is also A. So both the triangles will be congruent, friends. Half AB sin theta in terms of area also they are equal. So half AB sin theta into 2. So AB sin theta. These are the three versions, mainly two versions only, right? Base into height is one version and AB sin theta. And that half d1 d2 sin theta is also there when diagonals are known. Diagonals, correct? Yes. All right. Now special properties of parallelogram. The first one, rhombus. You know, a parallelogram gets converted to rhombus when all sides are equal. Opposite sides are equal already. So when any adjacent side become equal, all four of them will become equal, isn't it? So the diagonals of a rhombus are the angle bisectors at, yes, vertices. And because of that, what happens? The diagonals of a rhombus are perpendicular to each other. Yes. And then diagonals of a rhombus divide it into four congruent triangles. Mean is this. So both these triangles are congruent. Same way, these two triangles are also congruent. So all four triangles become congruent. If you know that also, then these 2 points will be taken care of, isn't it, friends? You can apply the properties of congruent triangles. All angles equal, all sides equal, like that. Okay. All right. Okay. So all the four triangles are congruent, because of which these two properties happen naturally. In parallelogram, opposite pair of triangles are congruent. All four are not congruent. Yeah. That's why you don't get this diagonals के बीच का angle as 90. Okay. Next, perimeter. Very simple. All four sides are equal. So 4 into one side, 4x. Area. Yes, just now we saw AB sin theta. So x into sine of this angle. That is why x square sine of this. Okay. Or x square into sine of this. 2o, whatever. And then one more thing is there, half into product of diagonals into sine of angle between them. And angle between the diagonal is 90. You know very well that sine of 90 degree is 1. All right. So half d1 d2. Perfect. Let's go ahead. Rectangle. So main feature was all angles are equal. Because of this, what happens, friends, if you visualize from this parallelogram shape, if it becomes this, so first thing diagonals will become equal. So rectangles has same diagonals, equal length. Both the diagonals will have same length. Yeah. Now this diagonal obviously divide into four triangles, but they all four are not congruent. But ironically, they all four have same areas. Area occupied by all four of them is same. Simple logical. Let's suppose this is L, this is B. So this is like from center to that point. This is height of this triangle. So B by 2. So half into L into B by 2 means this will be LB by 4. This will also be LB by 4 because they both are anyways congruent. This one for this triangle, this will be L by 2, right? And this is B. So this area will be LB by 4. So that way, each triangle has area LB by 4. So all four of them have same area, even though all four are not congruent. Okay. Perimeter 2L plus 2B, right? Area L into B. Remember AB sin theta, L into B into sin 90. Sin 90 is 1. Or half D1 D2 sin theta. D1 and D2 both are same because diagonals are of equal length. And angle between them exact value we don't know. So sin theta in general. So this much thought should be there in your mind. So you can also call it as like all rhombi are parallelograms, but reverse is not true. All rectangles are parallelograms. Reverse is not true. So these are like additional properties. They all have all the properties of parallelogram plus these properties. Yes. Square. Now what to say? Whatever we studied till now about parallelogram, rhombus, rectangle, everything is true. The diagonals are equal, angle bisectors, and perpendicular. Okay. So equal diagonals, they bisect the vertices angle, angles are vertices, they're perpendicular to each other, they bisect each other, all are true. The diagonals of a square divide this into four congruent triangles. Yes. Perfect. Perimeter 4 into side, all sides are equal. Area x into x into sine of 90 with respect to side, right? X square it will be. Or in terms of diagonals, half d square, right? Because the angle between the diagonals is also known, that is 90, isn't it? So half d square. Yes. So by comparing these two, so half d square is equal to x square. So d square is 2x square. So diagonal is x into root 2. So here we have root 2. Okay, so diagonal is root 2 times side. That we know anyways already. But this is 45, this is 45 friends, and this is 90. 40, 45, 90 theorem, remember special triangle. This will be x root 2. Yes, you can connect all of them. Maza aata hai, isn't it? Once you know all the rules of the game properly, खेलने में क्या मजा आता है? You play it like a pro. We are learning all the rules only. Next parameter, if you remember, was trapezium, when only one pair of sides is parallel. So these were the parallel sides. The non-parallel sides are called as oblique sides. Address में लिखते हैं ना A oblique 103. We generally call that slash or a line as oblique. So non-parallel sides are called as oblique sides. Yeah. Now, if oblique sides are equal, then that trapezium is called as isosceles trapezium. Okay. Now, one more thing, friend. Let me derive here only. Perpendicular drawn from both these vertices to opposite side. If it is isosceles trapezium, these two are equal. These two are already equal. Distance between the parallel lines. So these two triangles are congruent by RHS test. So if this is x, this is also x. So both these angles will be equal. Similarly, this is 180 minus x, 180 minus x. So they are also equal. So both the pair of base angles are equal. Okay. All right. Now, next thought. So you can see this triangle ABC, yeah, and then you can see BDC. Both of them will be congruent, isn't it? Because this equal to this isosceles trapezium. Just now we proved this angle equal to this angle, and this is the common side. SAS test, side angle side. So this has to be equal to this. That is why we say the diagonals of isosceles trapezium are always equal. This much you should know about isosceles trapezium, friends. Okay. All right. The diagonals of a trapezium cut each other in the ratio of the parallel sides. Isn't it? Easy to prove. Both these triangles will be similar, friends. Isn't it? Remember application of similarity. वो Z बनेगा alternate angle से दोनों भी triangle similar हो जाएंगे. Then ratio of the sides. वही तो लिखा है. Perfect. The two triangles formed by the oblique sides and the diagonals of the trapezium will have equal areas. So basically these two. Why so? Now see. Triangle ABC and triangle BDC are congruent, so they will have same area. And this is the equal part which you are removing from them. So बचा हुआ part भी equally होगा ना? Yes, that was the logic. From two equal things, you are removing two equal things only. So remaining things will also be equal, right? So 10 equal to 10, I am removing 2 from them. So 8 equal to 80 होगा ना? Yes, that way. Logical proof. Yes, and the line joining the midpoints of the oblique sides is called as median of the trapezium. Okay, friends, median of the trapezium. And the median of the trapezium is parallel to the parallel sides, and its length is average of their lengths. You can easily draw two triangles and you can apply midpoint theorem, basic proportionality theorem. You can prove this. Okay, so median is half into S1 plus S2 or average of the length of the parallel sides. Yes. Perimeter, sum of parallel sides plus sum of oblique sides. No fixed formula as such. Area. Yes. So this is the height of the trapezium, the distance between the parallel lines. So half into sum of parallel lines into h. Again, you can draw two triangles and you can add the areas of the both. By the way, this is also median, right? You can also see area as median into height. Okay. All right. Finally, the last one, kite. For this shape to be kite, first important property, is this kite? No, right? So what do you conclude logically? This is visualization. Both the pairs of adjacent sides should be equal. See this? Okay. Yes. Now this diagonal will be perpendicular to this diagonal. Let's derive it logically first. If I draw this diagonal, it divides into two triangles. Now both these triangles will be congruent, isn't it? Because this is common side and other two sides are also equal. So S test. So this angle equal to this angle, this angle equal to this angle, this angle equal to this angle. All right. Properties of congruent triangles. All sides are equal, all angles are equal. Yes, that way. If I draw this other diagonal now, just check these two smaller triangles. This is the common side. Yeah, these two sides are equal. XX equal to SAS test, isn't it? So this will be equal to this congruent sides of congruent triangle. And both these angles add up to 180, but now both are congruent. So each will be 90. Hence one diagonal bisects the other diagonal at 90. देखा triangle से सब कुछ कैसे prove हो रहा है? So triangle has to be very, very strong. Now you know the reason. The diagonals of a kite are perpendicular to each other, and one of the diagonal bisects the other one, and it also bisects the corresponding vertex angle. Just now we proved it, right? Yes. Perimeter, yes. 2A plus 2B. Area, we know the angle between the diagonals, so we can take use of that formula, half d1 d2 sine theta, and sine 90 is 1. All right. Cool. Yes. This much you should know about kite, friends. Correct. That's it. In polygons and quadrilateral, this much basic information is good enough. Obviously, along with all the knowledge of triangles. Okay. Thank you for giving your precious time. I hope you have made the notes. Keep revising, make it strong, and then we'll solve more sums in the class. All right, champions. Thank you so much. Take care, stay safe, stay focused. Bye bye.